Hey kids, let's take a look at the lesson that we have been working on, a review of equations. And pardon me for just one moment while I grab my shared screen. And over here we go. This is called Practice, Write, and Solve Equations. You can take notes right on the Pear Deck to help you pass the quiz. All right. So let's get started here. Pardon me for just one moment. Let's present this as a slideshow. Okay. And so the very first one is not so bad. Solve the equation. Some number minus 12 is equal to 20. Why don't we start off with blue? So if I add 12 to both sides of the equation, right? The opposite of negative 12 is positive 12. So those are being opposite integers that they cancel each other out, right? So that means that negative 12 plus positive 12 is 0. It's just 0 is nothing. We don't have to write it down, right? It doesn't, you don't have to write s plus 0 because it's nothing. Well, 20 plus 12 is equal to 32. So s must be 32. How do we know that s is equal to 32? You go back and you check your work with substitution, right? So 32 minus 12 should be equal to 20. And 32 minus 12 is 20. 20 does equal 20. That's how we know our answer's right, with substitution. Okay, let's move on to the next question here. Miguel is posting photos on a school website. He has 48 photos and he is allowed to use 12 pages. He wants to put the same number of photos, P, on each page. So he wants to put the same number of photos on each page. So if he multiplies the number of pages times the number of photos, right, he will get 48, which is how many photos he has. So if we would use a working backwards strategy, right, to solve this equation, we could have just divided 48 by 12 and found out the number of photos, right? Well, that's the same way we're going to solve the equation. We're going to do the opposite of multiplication, which is division. Okay, and so P is equal to 4. So there are 4 photos on each page. How do we know we're right? We know we're right because we could plug back in for P. 12 times 4 should equal 48. And you could come off to the side. Who needs a calculator, right? We don't need no calculator. Look at that. 12 times 4 is indeed 48. Okay, fair enough? All right, let's move on to the next problem. An onion soup recipe calls for 3 2/3 cups of chopped onions. Katrina has already chopped 1 1/3 cups of onions. She wants to know how many more she needs to chop. Let X be the number of cups of onions Katrina still needs to chop. Write an equation to describe the situation. So we could start with the 1 1/3 cups that she has, right? And so you would drag this little piece first, right? 1 1/3. And if we would add to that, some unknown number that she still needs to chop, right? All together, total, we would get a total of 3 2/3 cups, right, of onions, okay? And that's not the only way to solve it, of course. That's just one way to write the equation. We could also start with the number of onions that she has, right? And subtract out what she's already cut and know that that's going to be how many she has left over, right? But that's exactly how we're going to solve it. We're going to solve it by subtracting 1 1/3 from this side. Oops, that's 1 1/3, Miss Rowe. And 1 1/3 from this side of the equation. So I ran out of room where I'm going to write. Let's come over here though and stacked up 3 2/3 minus 1 1/3. Well, 2/3 minus 1/3 is 1/3. 3 minus 1 is 2. So it looks like our final answer is 2 1/3 cups. Katrina still needs to chop 1 2/3 cups of onions. How do we know it's right? Again, you can come back and check your work because 2 1/3 plus 1 1/3, and I changed the order there, sorry, but addition order doesn't matter, right? Should equal 3 2/3, and it does. So that's how we know we're right. Okay. Let's move on to the next question. The sum of 7.2 and a number is 10. So the sum of 7.2, sum means what? Sum means to add, okay? So the sum of 7.2 and a number, which is what we don't know, that's why I'm using X, is a fancy math way of saying equals. All right, is, you know what? That X is like horrible. Let's erase that X. It doesn't even look like an X. We'll fix it then. Go back to the pen. 7.2 plus some number, well, that one's not much better, okay, is going to be equal to 10. So you drag the 7.2, right? 7 2/10 plus some unknown number, which is X, is equal to 10. Okay. So now that we have our equation, what is the number? 7.2 plus some number equals 10, right? Are you with me? Okay. So what's the opposite of adding 7.2? How do we undo a positive 7.2? Remember, we want to use opposite values because opposite values make 0, right? So the opposite of positive 7.2 is negative 7.2. So we're going to subtract 7.2 from this side and subtract 7 2/10 also from the other side of the equation. That way, these two guys cancel each other out. 7 2/10 minus 7 2/10 is 0 on this side. That's what we want. We want to isolate X. That's our goal. Get X all by itself. X is a diva. So 10 minus 7.2 is that 2 8/10. Let me just use substitution to check my work, right? Because 7.2 plus 2.8 should be equal to 10, right? And I'll just come off to the side here. Since my calculator's not handy, right? 7, 8, 9, 10, boom. Very good. We are indeed correct. Okay, so that number is 2 8/10 that we're looking for. That's what x is equal to. Okay, another really simple one, not too bad. We're going to use opposite integers. Let's use purple this time, right? How do we undo subtraction? What's the opposite of subtraction? Addition, right? So if we add 14 to this side of the equation, then we add 14 to this side of the equation. So again, negative 14 and positive 14, they cancel each other out, right? That makes 0. Okay, and 30 plus 14 is indeed 44. We can check our work. Let's go back and check our work and make sure that we did it right. That's the nice thing about equations, is that you can always check your work with substitution. 44 minus 14 should be equal to 30, and 30 is equal to 30. Yay, that's a true statement. That's how we know that t is definitely equal to 44. I don't think you guys like my script t's, but that's indeed supposed to be a t, just so it makes it look different than a plus sign, okay? All righty. Kayla and her friends are setting up chairs for a school play. Each row will contain the same number of chairs. Kayla knows that there are 96 chairs in all. She wants there to be 8 rows. Kayla needs to know how many chairs C should be in each row, okay? If there are 8 rows, and maybe I'll draw a diagram just to make sure I've got this right. 1, 2, 3, 4, 5, 6, 7, 8. Those are my 8 rows. And so I'm trying to visualize it, right? So my 96 chairs need to be divided up among those rows. So if I multiply the number of rows times however many chairs are in each row, right? And I'm just hypothetically saying, well, what if there are 4 chairs in each row? All right, that would tell me how many chairs should be in each row, right? Okay, again, that's just me explaining my thinking, how I draw a really simple diagram, okay? So the number of rows times the number of chairs will equal 96. How many chairs C should be in each row? So how do we solve an equation that has multiplication? Well, we use the opposite, which is division. So the opposite of multiplying by 8 is dividing by 8. And 96 divided by 8 is 12. So there are indeed 12 chairs in each row. You can come back and you can check with substitution. 8 times 12 should be equal to 96. This step right here makes sure, I wrote 36 and said 96, sorry kids. This step right here makes sure that I don't do the problem incorrectly, right? 8 times 12 should equal 96. And then when I check, oh, well, 96 is equal to 96. That's a true statement. So definitely there are 12 chairs in each row. That's how I know, okay? A lasagna recipe calls for 3 3/4 cups of tomato sauce. DeMarco already has 1 1/4 cups of tomato sauce. He wants to know how many more cups of tomato sauce he needs. Let Y be the number of cups of tomato sauce DeMarco still needs. Write an equation to describe the situation. Okay, DeMarco already has how much tomato sauce? He has 1 1/4 cups. So that's what he's starting with, right? If we add to that how much tomato sauce, much more tomato sauce he needs, we don't know how much that is. We'll call it, oh, I put X, but they're using Y. I don't want that to be confusing. It doesn't matter what variable you use, truly, but they said let Y be the number of cups of tomato sauce. Okay, well, that's fine. We'll use Y. All right, so 1 1/4 plus Y will be equal to the total amount of tomato sauce that he needs. And how much does the recipe call for? It calls for 3 3/4 cups altogether. Okay, so you start out with 1 1/4 cup and you add to it however much more he needs to make. And so altogether, that is equal to 3 3/4 cups of tomato sauce. Now I have a feeling that you guys already know what's going to happen here, how we're going to find out how many more cups he's going to need. Well, I am going to use opposite integers, right? In this case, so they're not opposite integers, though, they're opposite values, because those are not integers, those are rational numbers, right? So I will subtract 1 1/4 from both sides of the equation, okay? So if I have 3 3/4 and I subtract 1 1/4, well, 3/4 minus 1/4 is 2/4, okay? And 3 minus 1 is 2, all right? So Y should be equal to 2 2/4. Okay, I want to let you know right away that that is equivalent, and we could simplify it to 2 1/2. They mean exactly the same thing, 2 2/4 and 2 1/2. They did not give us the specific instruction to simplify. You should always simplify your fractions, but if you put it in as 2 2/4, they do count it as, since it's equivalent. I imagine they'd also count it if you put 2.5, but 2 1/2 is sufficient because all those things mean the same. The product of 2.5 and a number is 10. So we're talking product here, guys. Product, all right? Product means multiply. 2.5 times a number, right? We don't know what that number is. Now, by all means, they have a multiplication sign here. If you put the multiplication sign in, it's not that it's going to mark it wrong, it's just equivalent. I want you to know that if you just put the variable z right next to it, then it's a coefficient. And so that's fine. If you put the multiplication sign or leave the multiplication sign out, they mean the same thing. So neither one. I just want you to know that that's a z and not a 2. That's why it's crossed like that. Is equal to, remember that's what is means. Is another way to say equals in math, okay? Is 10, okay? So let's read it back and make sure that we've got it, okay? So we've got the product of 2.5 and z, so those are being multiplied times one another, is, which means equals 10. So I'm satisfied that we did that correctly. Okay, so what's the number? All right, if we have multiplication and we want to undo it, the opposite of multiplication is division, right? So I should divide both sides of this equation by 2.5. And 10 divided by 2.5 is 4. And again, if I plug that back in and say 4 times 2.5, that should be equal to 10 if I use substitution. Okay. Don't forget about your independent practice if you haven't already completed that S9 solve equations, complete the solution, because it takes you through 2-step equations and that process. Okay, these are all 1-step equations, but 2-step equations are pretty much the same thing. Okay, bye kids, thank you.